Greetings, Math 122. This is pre-calculus, and we are jumping into section 2.2. We are talking about higher degree polynomial functions, and so these are functions that are maybe x cubed or x to the fourth or x to the fifth. So those functions behave in a way, the even numbers will behave in a way similar to x squared, but x cubed takes off in two different directions. The two ends take off in different directions. If you remember back to our parent functions, that gives you a hint as to what's going on. So we're going to talk about some transformations. We're going to find the zeros, and we're going to talk about how to graph those. So again, I will have the PowerPoint going, and we'll let you know what slide I'm on as we go. So this is slide number 6. First concept we want to talk about is being continuous. So a very, very simplistic approach. It is not a mathematical discussion. It is not a mathematical explanation of what it means to be continuous. But at this point, it works pretty good for us. So if I have a function that I don't have to pick my pencil up, my marker in this case, if I'm not picking my pencil up, that's continuous. However, if I have something that looks like, let's switch to red, where I come up and I stop and then I jump down here and I take off again. So if you look at that red graph, that is not continuous. That would be something that has a discontinuity. I had to stop, pick up, and head to another location. So a second feature is this idea that they have to be rounded. So I cannot have something that makes a sharp turn. So if I have a graph where I come down and back up again, and you might recognize that as an absolute value function where I can't have any negative values, this is not going to work. That is not something that is a smooth, continuous function. So in the concept of continuous. We also want to talk about the zeros. And in this case, my zero is right here, but again, that's not continuous. But if I have a nice, well-behaved parabola, then my zero is down here. And that works pretty good. Let's see. So I'm going to pick this up for a minute and bring this over a little closer because they do a really nice job of explaining what different powers. So if you look at the graphs on your left over here, I have x squared and I have x to the fourth. So you'll notice they're very similar. If you didn't have them laying next to each other, you might not know the difference. But the x to the fourth is the heavier line that's flatter on the bottom. Because what happens is that in that section, and take note of where the 1 and negative 1 are, in that section between 1 and negative 1, where you have values that are fractions or decimals that are less than 1, what happens is those values tend to stay small longer, the higher the power, and then as soon as you get past 1, it takes off faster. So if you thought about squaring 0.01, that's going to still be a very small number, or 0.05, like maybe that's about negative 0.05. That would be positive 0.05. But then all of a sudden it takes off faster. So think about taking 10 squared is 100. 10 to the fourth power would be 10,000. So all of a sudden that takes off much faster. X cubed versus x to the fifth power displays a similar behavior. Their ends, as it's negative, their end goes off to negative infinity. The positive side goes off to positive infinity. So again, those two things happen more quickly the higher the power is. So that can kind of be a guide to help you keep track of how that works. All right. So if we were to sketch graphs of negative fifth. And anyway, again, I'm gonna pick this up just because it does such a nice job of explaining what that picture really looks like. So this is the negative of x to the fifth. So since there's a negative sign out front, we know that it flips over the x-axis. So if it was positive, it would be flipped. This end would be down, this end would be up. So we know that it is negative, so it's flipped over the x-axis. And I have f of x equals negative x to the fifth. Sure enough, it passes through 0, 0. It stays flatter longer. The higher the power, it stays flatter between 1 and negative 1. And then it takes off very quickly. All right, let's look at this next one. So in this case, this is x to the fourth. But it's not just x to the fourth, it's x plus 1. So we remember from all our transformation work that if the value is inside the x, inside the function is the way I like to say it, but inside those parentheses, you have to take the opposite sign. So this moves to the left one because inside the parentheses it's x plus 1. And again, it's going to be flat longer in the middle, and then it'll take off faster. So we could plug some values in and plot that. That's helpful to get started, but you will get pretty comfortable with how to graph these without having to actually plot points. All right, so leading coefficients. So what is my leading coefficient? So if I had f of x equals 3x cubed minus 2x plus 2, this 3 is my leading coefficient, right? And I see that that's a positive number. If I had f of x equals negative 2x to the fourth minus 3x plus 6. Oops, let's put a cube on that. 6x squared minus x plus 1. My leading coefficient is this negative 2. And I notice that's negative. So that tells me what's going to happen with the ends. What's the end behavior? We know if it's a positive value, this will behave very much like an x cubed. If this is a negative value, it's going to behave like x to the fourth, but I have to flip over the the x-axis, just as we did with this one here. So this leading coefficient, excuse me. So let's see what happens with my ends. I am on slide number 17, if you're following along. And I'm going to draw this. This is an x cube parent function here. So the parent function is f of x equals x cubed. This is obviously not x cubed because it's shifted over, but it's some sort of, it's related to that. So there are functions that are, remember we call those odd functions. So when n, this is my n, when it's odd, that's the situation we're talking about. And just a reminder, our general equation for functions, oops, that's supposed to be an a to the 1, x plus a sub 0, x to the 0. So that's kind of our general format. If this highest power is an odd function, then it has some sort of behavior where one end goes one direction and one end goes the other. If this leading coefficient is positive, leading coefficient is positive, then the left hand goes to negative infinity and the right hand goes to positive infinity. And I bet you could guess what's going to happen next if I looked at a graph that had a negative leading coefficient. So let me see if I can draw something like that. So So if the leading coefficient is negative, ran out of space there, sorry. If that leading coefficient is negative, and again we're talking about odd functions, so that's this power, the highest power. And the reason why we look at the highest power is that's the piece of the puzzle, that's the piece of the function that's going to make it take off quickly. So my leading coefficient, the variable with the highest power, that's what's going to determine the behavior. Think for a minute, if I took 1,000,000 and took it to the 4th power, that's going to be way bigger than 1,000,000 to the 3rd power, right? So that leading coefficient is the one that determines what happens with this function. So if my leading coefficient is negative, it flips over the x-axis. So in this case, the left-hand end goes to positive infinity, and the right-hand end goes to negative infinity. And this is not something that I expect you to memorize. This is something you ought to learn. This is something that you should be able to step back and go, okay, I have an odd leading coefficient. And the cool thing is literally you can look at just that leading coefficient. It's the only piece of the puzzle you really have to look at. I can look at just that leading coefficient. If it's odd, it's going to have, the two ends are going to do two different things. If it's even, we'll look at that in a second, they're going to go in the same direction. If it's positive, well, the smaller, the more likely it is to go to a negative value. This right end gets bigger and bigger and bigger. That becomes more positive. It goes on to positive infinity. If the leading coefficient is negative, it flips upside down. So then this left end goes to positive infinity and the right end goes to negative infinity. Again, it's all very logical. You don't have to work too hard to memorize something like that. And honestly, that's the logic that I hope that you get a good grasp on. All right, so what if that leading coefficient is an even number? So when I have some sort of even number, so let's just write that down, leading coefficient is even, all right, and this is slide number 18. If the leading coefficient is even, maybe it's something that looks like this cute little graph where the two ends go off. If it's even, the two ends are going to go in the same direction, so that's actually a little simpler. So if the coefficient, you know what I just wrote, sorry, leading coefficient, this is the leading term, is, has, let's change that article there, has an even power, so it's even power, then both ends head in the same direction. If the leading coefficient is positive, then both ends go to positive infinity. If the leading, oh, I'm sorry, I'm standing in the way, sorry. If the leading coefficient is negative, then it goes to negative infinity. And both ends go in the same direction. So both ends, same direction. All right, so both ends head in the same direction. If I had a graph, maybe it was a very gentle parabola. So that's y equals x squared, or let's just say that's the parent function. It's obviously not, but we know that there would be a negative in there. So that leading coefficient would be a negative x squared. So both ends are going to go down to negative infinity. All right, let me erase this. So we want to look at left-hand behavior for some functions here. So if f of x is equal to negative x cubed plus 4x, so we're asking ourselves, is this highest term, is that even or odd? Well, it's odd. And the leading coefficient is negative. So I know the two ends are going to head off in opposite directions. They're going to head off in opposite directions because the power is negative, and because the leading coefficient is negative, we flip. So the left hand goes to negative infinity. Whoops, I just did that backwards. The left hand goes to positive infinity, and the right hand goes to negative infinity. Okay? What about f of x equals x to the 4th minus 5x squared plus 4? So this leading term here has a positive exponent, or an even exponent. That's x to the 4th. So that's even. And the coefficient looks like it doesn't have anything, right? That's what it looks like. But it's a positive one. So it's positive. So we know that both ends are going to head in the same direction, and they're both going to be positive. So both right hand and left hand goes to positive infinity. All right, let's look at the last one. We have f of x equals x to the 5th minus x. Again, I'm going to look at this highest power. This highest power here is odd. It's an odd number, it's a 5. And this coefficient, again, it looks like there's no coefficient, but really there's a positive one. It's positive. So I know that the bigger the x value, the bigger the value of the function, because literally this x to the 5th is going to get big so much faster than this x that that's really all you have to worry about. So my right hand goes to positive infinity, my left hand goes to negative infinity. Because let's say I put a negative 10,000 in there for that x to the 5th. Wow, it's heading south. That's a pretty big negative number, if I can say it that way. So let's look at these. I'm going to pick this up for a second so you can kind of just see this better. So if I have f of x equals negative x cubed plus 4x, then I see that the left end goes to positive infinity and the right end goes to negative infinity. This was the f of x equals x to the 4th minus 5x squared plus 4. Both ends go to positive infinity. It's an even function. That leading coefficient or leading exponent is even, and leading coefficient is positive, so they both go to positive infinity. If I look at f of x equals x to the 5th minus x, the highest power is the to the 5th power. That's an odd number, and my leading coefficient is positive, so my right end goes to positive infinity and my left end goes to negative infinity. All right, now let's see. So let's keep going. Okay, so I'm actually going to stop there. I'm going to do this in a couple parts. This talks about real zeros, so I think we'll stop here.